are done on the breadboard, the LED is on. Okay, but make sure that the positive of the battery should be connected to the anode and the negative of the battery should be connected to the cathode. That is the minimum requirement, because we know that diode, okay, LED is nothing but your light emitting diode, and diode always works in a forward bias. Okay, so this is the thing that I want to explain with you. Now next one is the introduction to Arduino Uno. So whatever the interfacing we are doing in this session, we will use this microcontroller, Arduino Uno microcontroller. Okay, this is the another version, is a SMD version of the microcontroller, but in a practical I'm not going to use the SMD version. I'm using the DIP version of this Arduino Uno. The price of the SMD version is somewhat less than the DIP version of the Arduino Uno. The price of the Arduino SMD version is nearly about the 450 rupees, and for DIP version it is about the 550 rupees. Okay, so you can get the less value Arduino also, because it is an open source board. Anyone can manufacture it. Okay, so we'll start with exploring what are the pins of the Arduino. Okay, so actually okay, thank you. First, what is Arduino Uno? Okay, Arduino Uno is a, you can say that it is a credit card size microcontroller. It is a credit card size microcontroller. We'll start with the definition. This definition is taken from the official website arduino.cc. So Arduino is an open source electronic prototyping platform. Okay, it is an open source electronic prototyping platform based on flexible, easy to use hardware and software. Actually, the intention behind invention of the Arduino is they want open source electronics platform which is very easy to use. It is very flexible to use, and its hardware and software are the open source. Okay, so it's intended, generally it is intended for artists, designers, hobbyists, and anyone interested in creating the interactive objects or the environment. Suppose if you have any idea in your mind and if you want to implement within a very short duration, then Arduino is the very best suitable microcontroller for you. Okay, so within a one day actually you can implement your idea. No need to go for the details of the microcontroller. Okay, in the year 2005, that the first ever Arduino board was born in the classroom of the Interactive Design Institute in Avera, Italy. Okay, so in 2005 the Arduino was born, and the Arduino project has been headed by the inventor Massimo Banzi. Okay, Massimo Banzi. This is the team Arduino developer, and here is a photograph of the Massimo Banzi. And this photo is taken from the IEEE Spectrum. Now these are some boards, types of Arduino boards. So actually this 1.5 years ago. Okay, so might be there is a more boards has been launched, more types of the boards is available. Okay, so I have to update this PPT. So Arduino is the very famous one. Leonardo is generally not using in India. Lily pad is the coin size Arduino. You can say it is a coin size, 1 rupee coin size. Arduino Mega is one of the, again, the useful board when you want the more IOs, input outputs, then you can go for the Mega. The Nano is also there, Arduino Nano. Mini is also there. So, and Nano and Mini is generally used when there is a size constraint is there. Okay, so if you want the less size microcontroller, then you can go for the Mini or the Nano. Okay, then Arduino BT is also there. BT stands from the Bluetooth. Okay, so it is having the inbuilt Bluetooth. Now again there are some shields are also available, Arduino shields. Now what are the shields? Shields are, it's a ready-made prototyping platform. Just you have to plug that Arduino shield on the Arduino board, and just you have to upload your program and you can test your program directly. You can test your whatever you have written. Okay, no need for the breadboard. No need for breadboard.
Call internet anta bartala adan select ಮಾಡಬೇಕು.
Okay, so thank you. So shields are piece of the hardware that you can mount on Arduino to give it a specific purpose or extra capability. For example, if your Arduino is not having the RTC, okay, generally Arduino is not having RTC. And if you want to give the RTC real-time clock to Arduino, then you can purchase Arduino RTC shield and just plug that RTC shield on Arduino, and now your Arduino is RTC enabled. Now, how many shields we can add? We can add the multiple shields. We can make a stack of that shield. So these are the different shields are available. Actually, the price of the board are nearly about 500 rupees, but the price of the shield is more than the microcontroller. One shield will cost nearly about more than 1,000 rupees, because shields are not open source. Now this is the description of the Arduino Uno. You can take a snapshot of this screenshot. You can take a screenshot of this slide also. Now Arduino Uno is having total 14 digital I/O pins. Okay, digital I/O means. Now first, what do you mean by digital I/O? Digital I/O means it is an input output. Okay, and it is a digital one. Digital represent it. We can send a 0 or we can send a 1. We can send 0 or we can send 1 to that pin on that, or we can read 0 or we can read 1 from that pin. So that is called as a digital IO pin. Okay, how many? Total 14 digital IO pins, but I prefer that I always using only the digital IO from pin number 2 to pin number 13. I'm not using the 0 and 1 for the digital IO, because the pin number 0 and pin number 1, they are having the dual role. Pin number 0 and pin number 1 you can use as a digital IO as well, or you can even use it for a serial transmission, RX or TX. For example, there is a Bluetooth device is there, and if you want to communicate with that Bluetooth device is also the serial output. So the RX of that particular Bluetooth has to be connected to the TX of the board, Arduino Uno board, and the TX of that Bluetooth module has to be connected to the RX of that Arduino Uno. This connection is called as a null modem connection, and I generally reserve this 0 and 1 for the serial communication. So always start with the pin number 2 to pin number 13. But out of that 2 to 13, so total 12 digital IO pins are available for programming. Out of that, 6 pins are the PWM output pin. The PWM represent pulse width modulation. So if you can send a pulse to this pin number 3, 5 and 6, 9 and 10 and 11, and you can vary the width of that pulse by using some command. Okay, there is one command called as analog write command. Using that analog write command, we can vary that particular pulse. And now there is some actuators are there. That actuators are generally behaving some different when they are receiving some different if they are receiving the pulse having the different width. For example, I have connected the LED to pin number 3, and suppose I am giving some less width of the pulse to that particular LED, then the LED brightness is less there. So in that way, I can vary the brightness of that LED by using the PWM signal. Also, we can control the speed of the DC motor by using the PWM signal. Okay, so got it. This 14 digital IO pins. The output of the digital IO is the 5 volt, and the maximum current is the 40 milliampere current. So you should also make sure that whatever the actuators you are connecting here, that actuator should not draw a current more than 40 milliampere. And if that actuators are drawing the current more than 40 milliampere, then your IO, digital IO, can be of no use. Okay, it can blast. Okay, so that's why make sure that your actuators having the or drawing the current less than 40 milliampere. Okay, now this is the LED power on, green or orange LED is there. So whenever you giving the power supply to this board, then the power LED will be on. So this is to make sure that you have connected the proper power supply to the Arduino Uno. This is only for indication purpose. Internally connected to the pin number 13. It is internally connected to pin number 13. So if you want to check, that this Arduino board is working fine or not, what you are generally doing, you are first checking the Arduino Uno board by blinking this pin number 13, and when you are making the blink on pin number 13, the LED remains, the LED also becomes blink. Checked it, so you can say that it is only for the checking purpose. Okay, and there is a reset button is also there. Suppose program is running, and if you want to reset that program, if you want to restart that program, you have to click on that button, you have to press that button, then the board will be reset. Now there is a USB connector is there. Okay, this USB connector called as a type B connector, through which the Arduino Uno get the supply. We know that the USB is able to give the 5-volt supply. USB having the USB wire is having the 4 wires. First one is the 5-volt, the last one is the ground, and the second one is the data plus and data minus. Okay, so out of that first and last wire, we can get the power supply to the Arduino Uno. So no need to give the external power supply to board directly if you are connecting this Arduino Uno board to directly our USB port. Okay, if the USB is not available, then you can power this board by using the DC power jack, using that DC adapter. Okay, the maximum voltage is the 7 to 12 volt. Okay, maximum is 12 volt, minimum is 7 volt. Okay, generally I prefer the 9 volt to 12 volt adapter. So there is a one internal regulator is there, that this one black regulator, it's called as a voltage regulator, 5-volt voltage regulator. If you are connecting the 12-volt power supply, then this regulator will convert that 12-volt to 5-volt, and using that 5-volt, your Arduino Uno will be on. Now next one is the analog pins are there. Okay, like the digital pins, through which I can get only 0 or 1. But suppose if there are some sensors are there which are giving the data in terms of the analog, like in terms of the 0 to 5-volt only. Okay, so then we can connect that sensors to these analog pins. In alternative, you can say that an Arduino Uno is having the 6 ADC, analog to digital converter, 6 ADC, A0 to A5, and the resolution of the ADC are the 10-bit ADC. Now the 10-bit ADC means the resolution means the minimum value that we can get is the 10 zeros. So 0 0 0 0, like 10 zeros. So in a decimal it is 0, and the maximum value is 10 ones, 1 1 1 1 1 1 1 1 1 1. Okay, like 10 ones. 10 1 means 1 0 2 4. Okay, 1023, sorry, 1023. So the minimum value is 0 and the maximum value is 1, maximum value is 1023, that we can get from that analog pin. Okay, so if the sensor are providing 5-volt, you are getting 1023. If your sensor is not giving any value, that is 0 volt, then you are getting 0 volt. If your sensor is giving the 2.5 volt to the ADC, then you are getting the 512. You are getting the data as a 512. Okay, so through which I can get that what is the voltage that is available on my ADC. So if I know the value, I can calculate the voltage in a reverse way also. Now there is a power in is also there. For example, if you have the battery, okay, 9-volt battery or 12-volt battery is there, and if you want to power up this microcontroller, you are not having the USB, you are not having the DC power jack. Suppose there is a robot is there and robot is continuously moving. So continuously moving object cannot be connected to USB or power jack. Okay, so that's why there is a battery connection is also given. So if you have the 12-volt power supply, 12-volt battery or 9-volt battery, you can connect that 12-volt or 9-volt battery to here directly. V in is the positive of the battery and ground is that ground of the battery. Getting this? So V in is for the connecting to the battery. Now the next one is the power out. Okay, suppose if you have powered up this Arduino Uno board by 3 ways. the battery or power jack or USB. And suppose if there is an actuator, that actuators require the power supply. For example, motion sensor is having its own microcontroller, and to power up that microcontroller we need to provide the 5-volt power supply to that motion sensor. So here we can get that 5-volt power supply. So it is a power out is there. 3.3 volt is also it is providing. Suppose if there is a sensors and actuators, or sensor, generally most of the sensors are there which are works on a low power. So low power sensors are used, are they require the 3.3 volt power supply. Okay, so reset is generally, suppose if you have pressed the reset, and if you want to reset the other circuit also, then there is a reset out button is there. Okay, so like this, and this is the major, it is the heart of the your Arduino Uno, that is Atmega328P-PU. Okay, this is the microcontroller that you have to use it, Atmega328P-PU. Actually, when you buy the microcontroller Arduino Uno board directly, this is the DIP version of the board, and now this DIP version of the board, this IC contains the inbuilt bootloader. It contains the inbuilt bootloader. So what is bootloader? Bootloader, you can think about like it is operating system of the Arduino. Okay, so bootloader is always placed at the very first memory locations, and whatever your program uploading, that is get placed at the after that bootloader. So bootloader will call your program. So you can say that bootloader is the operating system of your Arduino Uno. So if the bootloader is present, then only you can program this Atmega328P-PU through the Arduino software. If the bootloader is missing, then you cannot program. So always make sure that if you want to program the Atmega328P, then that IC should have the bootloader installed in it. You can manually install also. Okay, if your my IC is not having the bootloader, you can manually install by using the breadboard directly. There are some videos on YouTube, you can go for it, how to download the bootloader or how to upload the bootloader on Atmega328P. Okay, the specification of microcontroller is given as 8-bit. It is a 8-bit microcontroller, 16 megahertz microcontroller. It requires a 16 megahertz crystal frequency, and this that crystal oscillator that we have given. We have to give the external crystal oscillator here, and 32 kilobytes of flash memory it is having. Okay, which is generally used to store your program. So 32 KB flash it is having. 1 kilobyte of the EEPROM it is having. Okay, so it is also having EEPROM. Generally EEPROM we can access when at the time when you are running the program. Okay, so suppose if when you are running the program and if you have the data, that has to be written permanently. So that permanent data you have to write into the EEPROM. Okay, whenever you read the data, that data is always in a RAM memory, and when your power is off, your RAM memory data will get off. Okay, so suppose if you want to store that data as a permanent storage, then you have to write that data in a EEPROM memory of the Arduino. Okay, it is having the 2 kilobytes of the SRAM. Okay, generally we know that the purpose of SRAM to store the temporary values. Now this is a specification that we have already discussed. Now this is the another microcontroller, Arduino Mega2560. It is, you can say that it is the another version of the Arduino, because if you see the this particular list, I am drawing the one. Okay, so this, just look at this one. Okay, this whatever the it comes in a that red square, it is just like your Arduino Uno, and this is the remaining is the expansion of the Arduino Uno. So it is, you can say it is an expanded version of the Arduino Uno, expanded version of the Arduino Uno. So what is expanded? So it contains the more IOs. It contains more IOs. So total 54 digital IO it contains, and total 16 analog inputs it contains. Now what is the major things again it contains? So it contains the major as a 16 analog pins, 54 digital IOs, and flash memory is 256 kilobytes. Okay, so previously for Arduino Uno it is only 32 kilobytes. But for Arduino Mega 2560, it is 256 kilobytes, out of which 4 kilobytes is used by bootloader, and here 0.5 kilobyte is used by bootloader. Okay. SRAM is 8 KB again. EEPROM is again increased 4 kilobytes of the EEPROM. The remaining is same. The remaining is same. Now we'll start with the programming, Arduino program development. Meanwhile, suppose if you have any doubts or if you have any question, then you can you can stop me and you can ask the question. So based on C++ without 80% of the instruction. So Arduino program, the language we have to use here C++ without 80% of the instruction. Okay, so you are doing the Arduino program, but you never think that it is a C++ programming. So programs are called as the sketches. So here it is a rename. Program are generally called as sketch. Sketches needed two functions, setup function and the loop function. So generally C++ program main function, but here in Arduino there is no main function. Only two functions are available, setup and loop. In a background there is a main function, but in a front end we have only two functions. We have to write only two functions, setup and loop. The setup is the first function to be called by the Arduino bootloader. So, and it is called only once. So setup will call first and once. But loop will be called after the setup has completed, and it will call again and again and again and again. It runs over and over and over until the power is lost or a new sketch is loaded. Getting this? So you can consider this loop as a while one loop. Okay. The loop function you can consider as a while one, that is an infinite loop. So whatever the statement you want to execute repeatedly, you have to write into the loop function, and then loop function will call again and again and again and again. Getting this? Yes, any doubt? The next one is the how to start the Arduino programming. Okay, so how many of you already know the Arduino programming? Just type me in a chat box. How many of you has already explored the Arduino programming? Just I'm waiting for 1 minute. Just type me in chat box. Or otherwise, how many of you are not explored the Arduino programming? Okay, just type not explored or Arduino not known. Okay, so anyone is listening me? Yeah. K Raja Shravan Kumar sir. Okay, thank you sir for replying. Okay, yes. Seema Nagarajan ma'am, thank you ma'am for replying. Shobha ma'am, thank you ma'am for replying. Actually, the problem with the Zoom session is that the most of the participants are joined the session and they are not actually listening that session. They only join and leave it. Okay, so that's why this meanwhile these questions are very important. So Abhi sir, thank you for responding. Okay, so not explore, so very good, because we are going to explore today. So download, first step is download and install the Arduino IDE. Okay, so that is the very first thing. Okay, if you want to use the Arduino software, you have to download it. So where from you download? You have to download from the website arduino.cc/download. Okay, and there is a free software you can download. No need to pay anyone a single rupees, but you can donate also. Okay, there is a donation. The arduino.cc, these are accepting the donation, $1, $2, $5, $10 donation you can do. Connect the board to the computer via USB cable. Yeah. Then if needed, install the driver. Actually, the driver get installed when you install the IDE. Then launch the Arduino IDE and select the board, select your board, which board you are selecting, because the Arduino is having the variety of the boards. So for which board you want to do a programming. So that's why you have to select your board and you have to select the serial port. Okay, what is the serial port? The serial port is the port through which you are downloading or you are uploading your program. Okay, we are uploading the program to the your Arduino board. Okay, open the blink example, upload the program, and you are done. You can in this way you can test your that Arduino board is working or not. Okay, we are doing that the same step here directly. I will be give the live demonstration. So this is the some screenshot. Software Windows installer. Yeah, just click on the Windows installer if you have the Windows operating system. If you have the Mac OS operating system, install on Mac OS X. If you have Linux operating system, just install the whatever the versions of the Linux you have installed. Okay. This is the sketch. Name is given, the menu bar is given, toolbar is given, serial monitor is having the separate icon, and then this is the editor where you can write the program, and this is the console where you are getting all the errors or the outputs you can get at the console. And at the last, there is status bar is there, and status bar you can make a status of the port is connected or not, at which port it is connected. Okay, so this is the sample. It is very similar like your other softwares. These some shortcut buttons are there on a toolbar. Verify, upload. Verify represent compile. Upload represent generally download. Okay, generally we refer the terms as a download to microcontroller, but here they have used the words as a upload to Arduino. Okay, so new, open, and save. These are some shortcut buttons are there. Now select the board. How to select the board? Just go to the tools, board, and just select the Arduino Uno. Okay, there are the lots of boards are there: Arduino Nano, Arduino Mega. Okay, so out of which you have to select only Arduino Uno. Now next one is port you have to select. Okay, how to select the port? Go to the tools, port, and whatever the ports. Now this port will become to your computer only when if you have connected the Arduino to your computer. Okay, if you have not connected the Arduino to your computer, then the port is not available here. Okay, there is no port, no such a port like COM6. Okay. Now we will discuss about the setup function, how to write the setup function, because you are the actually faculties of the computer and IT, so that's why I don't have to explain how to write the function. Okay, so what is function? It is a function definition. It is a block of the code, and these are the statement inside the block. Okay, and whenever we call the setup function, actually the statement get executed. But we are not calling the setup function. Setup function will be called at the start of your program. And who call the setup function? The bootloader of your Arduino will call it. Where is the bootloader is present? Bootloader is present in your Atmega328P. Now loop function, whichever code you want to run continuously, you have to put it in a loop function. Okay. Okay, so this is a sketch actually how to write the one Arduino sketch. The statement or the variable you want to declare as a global variable. So what is my global variable? The variables which can able to access by the multiple functions. That variables are called as a global variables. And what are the local variables? If the variable is declared within the function, that variables are called as a local variable. Okay, suppose if you are declared the local global variable as a LED equal to 5, so it means that my LED is connected to 5. So that LED variable I can use in a setup function as well as in a loop function. So in this way you have to follow that particular program. Okay, don't declare the local variable if you want to access that variable in another function. Now this is the one program is a constant variable. Generally all the declaration you should make as a constant if you have to make it as a constant if that particular pin is you are not going to change anywhere. For example, LED is connected to pin number 5, then you should make the statement like const int LED equal to 5. So whenever meanwhile, suppose if you are trying to make the change LED equal to 10, okay, then it should give the error. Okay, they just like a C and C++ program, nothing else. Okay, variable, if you are given the if you are not giving the variable as a constant, then that value can be changed anywhere. Okay, these are some important functions. Serial.print, this function will print the value to the serial monitor on your computer. Okay, so suppose there is one sensor is there. If the sensor is connected to Arduino Uno, and you have read the value of that sensor and you want to display that value to your computer, then you have to use this serial.print function. Okay, so it will print the value to a serial monitor on your computer. Pin mode function generally used to configure the mode of your pin mode. It configure the pin mode. It configure the mode of pin. What pin? Now there are only two modes, input and output. So first it accepts the two parameters. First parameter is the pin number and second parameter is the mode, input or output. Digital read function and pin, it accepts only a single parameter. It reads the digital value high or low on a pin which is set for the input. Suppose if the pin number 2 is connected to the switch and you want to read the status of that switch, it is press or not press, then you have to use the digital read function, digital read to pin number 2. Digital write function is generally used to write the digital value to the pin which is set for the output. Okay, for example, LED is connected to one of the pin and you want to write a high to that pin, then you are doing digital write. Suppose pin number 5 comma high. So 5 comma high means you are writing 5, you are writing high to 5, you are writing high to 5. So at pin number 5 there is a 5 volt is available. Getting this? So next one is LED interfacing. So this diagram of the LED interfacing, we have already explored how to make a connection of the LED. First, we know that LED, what is LED? Light emitting diode, which is having the two terminals, anode and the cathode. Anode is the positive terminal, cathode you can say it is a negative terminal. Okay. And we require one more device that is called as a resistor. Okay, so you can select the 100 ohm resistor for the brighter result, but I prefer 330 ohm resistor or 220 ohm resistor, but for demonstration purpose I always use the 100 ohm resistor. Okay, so how the connection is made, it is been shown here. It is being shown here. Are you able to see the connection? So this is the connection that we have made. You can see here, this is the cathode terminal. Cathode terminal is connected to the ground, and the anode terminal is connected to the one of the terminal of your resistor, and the second terminal of the resistor is connected to the where? Pin number 30. Getting this? Pin number 30. So such a type of the such type of your connection you have to make, and then we'll move towards the program. The program is very easy. Suppose LED is connected to pin number 13. So what we have to do? We have to do the pin number, we have to declare the pin number 13 as output firstly. Okay, before using it, before using the your pin number 13, you have to set the mode of that pin. Okay, because the pin number 13 can be used as an input as well as you can use as output. So we have to tell to the microcontroller that pin number 13 I want to use as output purpose. So use the function pin mode function. Make sure that M is capital, P is small. Okay, it follows that syntax, that is the first word for starting letter should be small and the second word starting letter should be capital one. Okay, pin mode, and it takes the two argument. First one is on which pin you have to set, pin number 13. Second argument is the what is the mode do you want to set. Output should be in a capital case. Okay, output should be in a capital case, because what is output? Output is the macro defined in the your Arduino. Okay, it is a macro defined. Okay, so macro, it is a macro, and macro we know that is always in a capital case letter. Okay, so output, so this statement will make the pin number 13 as an output. Getting this? Now where to write this function? Where to write this function? We have to write this function in a setup, because we have to set the mode of the pin number 13 to output only once and at the start. Okay, at the start and only once. So that's why, which is the best function to give to write the pin mode? Setup function. So setup function will execute the pin mode 13 output at the starting. So pin number 13 becomes the output, and now I can use the pin number 13 whatever I want to use. Now next one is program is LED blinking program. Now what do I blink LED? The blink LED, nothing but the first one is the LED is on, then there is some delay, then LED off, then some delay. Okay, why we put a delay? Why we put a delay? Because if you are not putting the delay, the microcontroller is such a fast that that blinking effect will not be visible to human eyes. Okay, actually it will blink, but that blink effect will not be visible, because we know that the persistence of vision, we can in a 1 second we can maximum view the 30 frames, but here the digital write 13 comma high and digital write 13 comma low will execute only for 1 microsecond. So for 1 microsecond it is high, and for 1 microsecond it is low. So that blink effect will not be detected by our human eyes. So in a loop function, what we will do, we'll write the high to pin number 13 first. We'll wait for some time. So there is a delay function. This is the inbuilt function. We don't have to implement it. There is an inbuilt function delay, and 1000 represent my millisecond. 1000 millisecond. We have to take the 1000 millisecond. We have to wait for the 1000 millisecond. The next one is pin digital write 13 comma low. So at the pin number 13 I'm sending low, that is 0, and then wait for the again 1 second. So what happened when you are sending 1 or 0 to pin number 13? Okay, so when you are sending 1 to pin number 13, when you are sending 1 to pin number 13, the pin number 13 is the 1 means 5 volt. So at this terminal there is a 5 volt. The second terminal of the register contains 5 volt, and we know, and the second terminal of the LED is directly connected to the ground. So LED is on. LED is on. Next one is when you are making the pin number 13 as a low, the anode becomes 0. The anode is 0 at 0 volt, cathode is also at 0 volt. So LED is off because there is no forward biasing. Getting this? So again, the timing is less than a minute. Shubha ma'am, are you there?
Yes, sir. Yes, sir.
Okay, so should we repeat the same step?
Yeah.
Yeah. Okay, so all participant has to rejoin again, because next one is actually practical session and very interesting session. Okay, so please rejoin. End the meeting and rejoin.